Hey guys, welcome back to the shop. My name is Brad. This is going to be the first in a series of short videos where I show how I make some projects for my paying customers. So I put together these little videos to kind of give you a little insight of Maple Lane Machine and Tools progress. So I hope you like it, and I'm looking forward to hearing your feedback. I first began by cutting the stock into workable pieces. The finished dimensions will be 1.25 inches by 1.25 inches by 1.5 inches. So we left them big to allow for machining. Deburring them to get rid of any saw marks, getting prepped for the vise. And we clean up our vise, get everything ready and clean so it will locate properly on the parallels. Now I'm using screwy balls from Chuck Bommarito to take up any of the irregular surfaces in the vise, and we smack it down to get it seated on the parallels. And here I'm using a 3-inch shell mill. This is a carbide insert tipped shell mill, and it just plows right through the material perfectly. I'm deburring in between each cut to remove any burrs, and you can see that we're pretty square here. I lift the square and then the light goes away, so we're pretty good. Now I used a fly cutter here to get some of the surfaces. I was experimenting to see which would come out nicer, and I thought this looked cool slowing it down. It kind of looks like it's shooting bullets at you. The next operation we're going to do is cut a slot along this axis over here, and it's going to be 360 thousandths deep by 260 thousandths wide. Now the tolerance on the depth is ±5, and the tolerance on the width is going to be +0, -2. So we could be a little bit smaller, but we can't be any bit bigger. Okay, so I got my vise stop installed and ready to go, and we're milling out half the depth now in one pass. And now with the second pass, we come in at full depth. Now for my finishing passes, I move the y-axis 5/1000ths of an inch and take a climb cut on each side. To check the slot, I made a gauge block stack 260 thousandths. This is the upper limit of my tolerance, so I know if I slide it in and it fits perfect, we're good. If it doesn't fit, we also know that we're good and we could always mill a little bit more. But if it's loose, then I know that I blew my tolerance, and luckily I didn't. And here we're just checking for depth, and we're pretty much spot on with that. The next operation is to drill a through hole. This will allow the tool block to be mounted to the machine it's intended for. The print calls for a number 7 drill, so we just drill right through. No need to ream here. And now we move over to the South Bend drill press for a little countersinking. I'm using a piece of newspaper to protect the aluminum from getting scratched or marred. Now the next operation is going to be to drill and tap 3 1032 set screw holes. And the DRO makes it really easy to drill the equally spaced holes. Use a little bit of WD-40 and do some power tapping. Now I'm being careful to watch my stop. I kill the power with enough time for it to coast almost to the stop, and then I back it out, and then I'll just finish them up by hand. Now I move the camera so you can see the quill as it moves down towards the stop. Now I set up the power and I run it, and then I kill it and let it coast almost until it hits the stop, and then I use the brake to slam it stop. Then I reverse it and back it out. And back over to the South Bend drill press to finish up the countersinks. And they came out really nice. Now the next series of 3 locating holes, I don't have video footage of me actually machining it, but I'll explain a little bit about it. There are 3 locating holes, 1 in each corner and then 1 on the front face opposite the through hole. There's a high tolerance for them within 5/10 thousandths of an inch. Now this hole right here is a through hole. It needed to be reamed and then it needed to be counterbored. And that was a little tricky and ran into a couple of problems, but we got it worked out and everything came out pretty good. The DRO again really helped with that, to hold those high tolerances. Now these last 2 holes that I'm drilling and tapping are going to be tapped at 632. I'm using the same method, power tapping slowly, getting it down to approximate depth, using the brake to stop it and then backing out. And now I'm just using a hand tap wrench just to get the holes down to their final depth. Nice and easy. Take up any slack that the power tapping didn't do. And lastly, to finish these blocks, we're putting a nice 45-degree chamfer on the edges. Give it a clean, finished look. And here's the final product, all finished and complete. Looking good and fully to spec. Now the real final step in all this process is to have the parts engraved with serial and sequence numbers, and then you can see we got the parts hard coat anodized. So they came out pretty nice. Alright guys, well I hope you enjoyed the video. Thanks for watching and remember to like and subscribe.